Dear all, let us continue the problem on superposition theorem. So using superposition theorem, find the current flowing through the 6 ohm resistor for the network shown. When we are applying superposition theorem, we need to consider only one independent source in the given network, and we have to make all the remaining independent sources zero. This is the concept of the theorem. So our intention is to find current flowing through 6 ohm resistor. So for this original network, let us assume the current flowing through the 6 ohm resistor as I flowing from A to B. I have marked the terminals A and B for my reference, and I am assuming current flow from A to B, that is I, in the original network when all the sources are present. Now what I will do, I will consider this voltage source, independent source, and I will make the remaining independent source 0. I am going to find the current. Let that current be I dash. Case 2, I will consider this current source and I will make all the remaining independent sources 0. Again I will find the current flowing through 6 ohm resistor. Let that current be I double dash. Then according to superposition theorem, the actual current flowing through 6 ohm resistor, that is I, is given by I dash and I double dash. This is the concept of the theorem. Now let us solve. Case 1. Consider 18 volt source and make the remaining independent sources 0. And very important when you are applying superposition theorem is you should never make dependent sources 0. Dependent sources should not be made 0 at any time when you are applying any theorem. It must be present in all the cases. That is very important. Now I am considering 18 volt source and I am making the remaining independent sources 0. You have only one independent source remaining here. Hence I have to make this current source 0. How to make the current source 0? By creating open circuit, because current is 0 under open circuit condition. Now let us rewrite the circuit. Keep the dependent source as it is. Rewrite the circuit. So I am creating one open circuit here. My intention is to find current flow through 6 ohm resistor. Let the current be I dash for the case 1. And very important is when there is a dependent source, the dependent variable must be given in the problem. So here this is a voltage source because polarity is given depending on voltage, that is Vx. Hence it is a voltage dependent voltage source. Where is the dependent variable? It is given here, Vx. That must be written as it is here. And when the dependent variable is voltage, they must specify the polarity of voltage. When the dependent variable is current, they must specify the direction of current. Now let us solve for I dash. You have only one loop. Let this current be I1. Now let us apply KVL to this loop. Very simple. So how we are following KVL? Left hand side of the equation we are summing all the voltage drops, and right hand side we are taking the voltage sources. When you are taking the voltage source, you have to take the algebraic sum of voltage sources. So let us write KVL now. So 1 I1 plus 6 I1 is equal to negative to positive is positive 18, negative to positive is positive, voltage value is 2Vx. So when you are writing KVL, all the equations must be in terms of loop currents when you are solving by loop analysis. If any dependent variable comes, that you have to replace by loop currents if you are solving by loop analysis. Now let us see what is Vx from the network. So but Vx is equal to, where is Vx? Here. Vx is a voltage. Voltage is equal to resistance into current. What is the resistance? 1 ohm. What the current? I1. Therefore, Vx equal to 1 I1. Is it correct or not? It's correct, but polarity we need to check if the dependent variable is voltage. So for this dependent variable Vx, I want voltage drop across 1 ohm resistor is Vx. I want the polarity for this Vx as left minus, right plus. So to get this negative, this positive, the current should flow like this. So when the current flows from higher potential to lower potential, we say that it is a voltage drop. But already I have assumed in clockwise direction, because this is the normal way we assume. I have not bothered about the polarity when I was assuming this current. Already I have assumed the current and I have written the KVL. Now just I am bothering about how to write Vx. So to get this positive and this negative, the current should flow from right to left. But already I have assumed in clockwise, that is current is from negative to positive. That is why the current what you have assumed should have been in opposite direction to get the polarity of Vx. That's why it should be minus I1. It is not just I1 here. I should take minus I1. It should have been in opposite direction. That's why Vx should be minus 1 I1. Very, very important. Vx equal to not just 1 I1. It is minus 1 I1. That is why this problem is given. Because most of the students will do mistake when you are writing this equation. That gives 7 I1 is equal to 18 minus 2 I1. If you substitute here, this becomes 9 I1 is equal to 18. Therefore, I1 is equal to 18 by 9 gives 2 ampere. I hope you have followed this concept of writing the KVL, and also why I have taken Vx as minus 1 I1. So this is what I1. I am interested in finding I dash. Therefore, so I dash is equal to what? I1. That is equal to 2 ampere. This is for case 1, the current flowing through 6 ohm resistor. Now let us go for case 2. What is the case 2? I am going to consider current source and I will make this voltage source 0. For case 2, consider 2 ampere current source and make the remaining independent sources 0. Okay, let us rewrite the circuit. So I am considering this current source, I am making this voltage source 0, keeping the dependent source as it is. You should not touch the dependent source. Now how to make this voltage source 0? You have to create the short circuit. So voltage is 0 under short circuit condition, current is 0 under open circuit condition. Now in this case, I am going to consider the current flowing through 6 ohm resistor as I double dash. Now let us rewrite the circuit. So I am considering the current source as it is. Now I have to create the short circuit here. Let us create the short circuit. Keep everything as it is. Now this is Vx, keep it as it is. This current I am taking it as I double dash flowing from A to B. So you should not change the direction of I dash, I double dash. It should be same as the original current, whatever you have assumed in the original network. Direction should be same. That is very, very important. Now let us solve for I double dash. Again let us solve this problem by mesh analysis. How to solve by mesh analysis? You know, you have two meshes here or loops. Let us take current flowing to this as I1. Take current flowing to this loop as I2. So KVL cannot be applied to first loop because we have ideal current source. Also KVL cannot be applied to second loop. Whenever there is an ideal current source common to two loops, KVL cannot be applied to those two loops. Then we have to write the current equation. The number of current equations is equal to number of ideal current sources that are present in the given network when you are solving the mesh analysis. Since we have only one ideal current source, now let us write first the current equation. So what is the current equation? So I am in this part of the wire, 3 ampere current is flowing upward. In the same wire, 2 loop currents are flowing. One is opposite to other. Hence I should take the difference of these two currents, that is I1 minus I2 or I2 minus I1, which is correct. So which is positive, which is negative? The loop current which is flowing in the direction of current source is taken as positive. The current which is flowing opposite to that will be taken as negative. That's why the current equation is given by I2 and this source current is matching now. So I2 minus I1 is how much? 3 ampere. That is I2 minus I1 is equal to 3 ampere is one equation. You have two unknowns. I need two equations, but you got only one equation. To get one more equation, we are going to form a super mesh. What is a super mesh? It is not a special mesh. We are going to identify a closed path where that path does not have a current source. Super mesh is the superposition of two or more meshes which is formed to avoid an ideal current source. Suppose if you avoid this ideal current source, assume that this is not there, then you are going to get a loop, a closed loop that can be taken as super mesh because this path does not have any current source. So that you are going to show in dotted lines to represent that it is a super mesh. So this is the super mesh. Now let us apply KVL to super mesh. So KVL to super mesh. Applying KVL to super mesh. 1 I1 plus 6 I2 is equal to what? Right hand side you write the voltage source. You are moving clockwise now. Negative to positive is positive to Vx. But what is Vx? You know already. Minus 1 I1. Vx is same. That's why substituting here. So 1 I1 plus 6 I2 is equal to minus 2 I1 it becomes. Take left hand side, it becomes 3 I1 plus 6 I2 is equal to 0, equation 2. So two unknowns, two equations. Put it in matrix form. Let us put equations 1 and 2 in matrix form. So I1, I2. First equation, coefficient of I1 is what? Minus 1. I2 is what? 1. Right hand side 3. Second equation, coefficient of I1 3. I2 6. Right hand side 0. So we want two equations. It may be current equation, it may be a voltage equation. I want two equations to solve two unknowns. So once you get two equations, put it in matrix form. Solve for I1 and I2, entering in calculator. Solving for I1 and I2, we get I1 is equal to minus 2 ampere. I2 is equal to 1 ampere. Now your intention is to find I double dash. Therefore I double dash is equal to what? You can see I double dash is equal to I2. That is equal to what? 1 ampere. Now so you got I double dash value. You got I1 value. Where is I dash value is 2 ampere. Now according to superposition theorem, so according to superposition theorem, the actual current flowing through 6 ohm resistor, that is I, is given by what? I dash plus I double dash. Algebraic sum of the currents which is considered earlier by considering only one source at a time. So what is I dash? I dash you got 2 ampere. What is I double dash? I double dash is equal to 1 ampere. Gives what? 3 ampere. So according to superposition theorem, the actual current that is flowing through the 6 ohm resistor is given by 3 ampere. I hope all of you have followed. Thank you for listening. Let us continue one more problem. Now let us solve one more problem on superposition theorem. Using superposition theorem, find the current flowing through the inductor. So inductor is given here, capacitor is here, resistor is here. So it is an AC network. Now you don't have any dependent source, hence you no need to worry about the dependent variables in this problem. All are independent sources. You have 3 independent sources, hence you have to solve this problem thrice to find the response, that is nothing but current flowing through the inductor. Now let us assume current flow through the inductor with the direction shown here. So let it be like this. So I want to find the current IL flowing from A to B. Now let us solve one by one. Now let us consider first this current source. Find the current through the inductor. Let that current be I dash. Case 2, consider this current source. Again find the current flowing through inductor. Let it be I double dash. Case 3, consider this voltage source acting alone. Make the remaining sources 0. Find the current through the inductor. Let it be I triple dash. Then according to superposition theorem, the actual current flowing through the inductor IL is given by I dash plus I double dash plus I triple dash. This is the concept. So case 1. Case 1. Consider 2 at an angle 0 ampere current source acting alone and make remaining independent sources 0. Independent sources 0. All of you observe here. Let us write the current source here. That is 2 at an angle 0 is nothing but 2 ampere only. Write the inductor, then resistor, say capacitor. Now how to make the current source 0? Create the open circuit. How to make voltage source 0? Create the short circuit. This is short circuit. This is open circuit. So this is J2. This is minus J1. This is 2 ohm. Now current flow is from A to B. Let this current be I dash for the case 1. Now let us solve the problem again by loop analysis only. Now let us take this current as I1. Let us take this current as I2. We have 2 loops. Now KVL cannot be applied to the first loop because you have an ideal current source. So I can write current equation. What is the current equation? So I1 is equal to 2 ampere. So current flowing to this part of the wire is 2 ampere. The loop current flowing to this wire is I1. Hence direction is also matching. So you can write I1 equal to 2 ampere. That means I got I1 value. Now let us apply KVL to second loop. Definitely you can apply KVL to second loop because you don't have any ideal current source. Now applying KVL to second loop. What is the KVL to second loop? So I am moving like this. Minus J1 into I2 plus J2 into what? I2 minus I1. 2 currents are flowing is equal to 0. Now let us simplify this. Minus J1 I2 plus J2 I2 minus J2 I1 is equal to 0. Now J2 minus J1 is J1 into I2 is equal to what? Minus J2. So it becomes plus, no sorry, into I1. You know the value of I1. So if you substitute I1 here, what happens? It becomes J2 into 2, J4. J2 into 2 is J4. So J4 you got. So J1 I2 is equal to J4. I want I2. Because I know I1, I want I2. So I2 is equal to what? J4 by J1. Okay. JJ you can cancel. If you cancel that, 4 by 1 is 4 ampere. What is I2? 4 ampere. What I want? I dash. What is I dash here? I1 minus I2. So I dash is equal to I1 minus I2. So I dash is equal to I1 minus I2. So what is I1? 2. What is I2? 4. Gives what? Minus 2 ampere. So I dash is equal to minus 2 ampere. Okay. Now let us go for case 2. So case 2, consider this current source, that is 2 at an angle 90 ampere current source, and make remaining independent sources 0. Okay, read the circuit. So I am considering this current source. Read this circuit as it is, 2 at an angle 90 ampere. So minus J1, this is J2, 2 ampere. We have a current source, create the open circuit. We have voltage source, create the short circuit. This is the circuit. Now your intention is to find the current flowing to the inductor. Let the current be I double dash. Direction you should not change. Keep the I double dash flowing from A to B. Now how many loops? You have 2 loops as usual. Let us take this current as I1. Let us take this current as I2, similar to previous case. So KVL cannot be applied to this loop because we have a current source. I can write current equation. For the current equation, I1 is opposite to the current source. Hence I1 is equal to minus 2 at an angle 90. Okay. You know 90 degree is nothing but J. Therefore I1 equal to minus J2 you can write. So in place of 90 degree I am writing J, remaining thing as it is. I1 is what? Minus J2 ampere. Now let us apply KVL to second loop. So applying KVL to second loop, as usual, here minus J1 I2 minus I1. I2 minus I1. You can see here 2 currents are flowing here, I2 minus I1, because we are considering second loop, plus J2. So only I2 is flowing here. I2 is equal to 0. Is equal to 0. Now simplify. J1 I2 minus into minus plus J1 I1 plus J2 I2 is equal to 0. Now what happens? I want what? I2, I1 I know, no? So let us simplify. J2, J1 is J3 I2 is equal to minus J1 I1. Correct? J2 plus J1 is J3. This is minus minus J1 I2. Sorry, this is minus, no, minus J2. Okay. This is plus. Okay. Now what happens? J2 minus J1 is J1. Okay. J1 I2. Take I1 to the right hand side, minus J1 I1. Okay. So I1 you know, substitute here. J1 I2 is equal to minus J1 into what is I1? Minus J2. Okay, very important, all of you observe here now. Simplification. So J1 I2 is equal to minus into minus plus J into J, J square, 2 into 1, 2. Okay, you know that J square value is what? Minus 1. Therefore J1 I2 is equal to, J square value itself is minus 1, it becomes minus 2. What I want? I want I2. Therefore I2 is equal to what? Minus 2 divided by J1. Okay. Now take J to the numerator. When you take J to the numerator, you have to take with opposite sign. It becomes minus J. Okay. Minus is already there. I am taking J to the numerator. It becomes minus J. Minus into minus plus J. 2 by 1 is 2. It is simplification. So you got I2 is equal to J2 ampere. Okay. Now what I want? I want I double dash. So I double dash is equal to what? I double dash and I2 is opposite, and I double dash is equal to minus I2. I double dash is equal to minus I2. That is I2 is J2, so minus J2 ampere. Okay, you got I double dash now. Now I have to find I triple dash by considering this voltage source. Now consider this voltage source, make these two sources 0. Okay, consider the voltage source and make remaining independent sources 0. Let us rewrite the circuit. Rewrite the circuit. Case 3. This is J2 minus J1. This is 2 ohm. So how to make these two current sources 0? Create the open circuit. I am creating open circuit here. I am considering this voltage source. Now rewrite this voltage source. Okay. Now polarity is important, plus or minus. This is 5.65 at an angle 135 degree. Okay. Now what is your intention? Current flowing through inductor I need to find. Let us mark that current as I triple dash. So mark here as I triple dash flowing from A to B. Now you have only one loop. Let this loop current be I1. Now let us apply KVL, solve for I1. Applying KVL here, very simple. So only one loop current I1 minus J1 I1 plus J2 I1 is equal to what? Minus 2 plus 5.65 at an angle 135 degree. Now J2 minus J1 is J1. J1 into I1 is equal to 5.65 at an angle 135 degree. Okay, what I want? I1. So I1 is equal to what? 5.65 at an angle 135 degree divided by J1. That is equal to 5.65 at an angle 135 degree divided by J means what? 90 degree, no? So I can write 1 at an angle 90 degree. This one J1 can be written as 1 at an angle 90 degree. Therefore I1 is equal to, so if both are in polar form, you can divide directly. What happens now? 5.65 divided by 1 is 5.65. If I take angle to the numerator, you have to take with opposite sign. Therefore 135 minus 90. Okay, that is 45 degree. Okay, or else you directly enter this in calculator. No problem, this can itself enter in calculator. One is polar, other is rectangle. Calculator will accept both the forms. You no need to do this manual calculations. Definitely you will get this answer. So what I want? I triple dash. What is I triple dash now? I triple dash is opposite to I1, hence it is minus I1. It is equal to minus 5.65 at an angle 45 degree. Then according to superposition theorem, what is the concept? The actual current IL is equal to I dash plus I double dash plus I triple dash. Now what is I dash? So I dash is equal to minus 2 ampere. So what is I double dash? I double dash is equal to, so minus J2 minus J2. So I triple dash is plus 5.65 at an angle 45 degree. So calculator will accept both rectangular and polar forms. Substitute to get the answer for IL. This is how to solve the problem using superposition theorem. I hope you have followed the concept. Thank you for listening.